For the differentiation example, find dy over dx if y is equal to 3e raised to the power of x sine x plus 4e raised to the power of x cosine x. The given function is composed of two terms involving trigonometric functions, because as shown in the board, we have sine and cosine. To solve, first apply the sum rule. With that, dy over dx is equal to d over dx times 3e raised to the power of x sine x plus d over dx times 4e raised to the power of x cosine x. Second is to find its derivative of each term separately through product rule. We use product rule for both terms because each term is composed of two factors. Next, we pair it diagonally. Three e raised to the power of x times cosine x plus 3e raised to the power of x times sine x. For the second term, negative 4e raised to the power of x times sine x plus 4e raised to the power of x times cosine x. Now, we combine like terms. Three e raised to the power of x cosine x plus 4e raised to the power of x cosine x, which gives us 7e raised to the power of x cosine x. 3e raised to the power of x sine x minus 4e raised to the power of x sine x. That's negative e raised to the power of x sine x. This leaves us the final answer, dy over dx is equal to 7e raised to the power of x cosine x minus e raised to the power of x sine x.
In addition to differentiation, we also have integration, which is like differentiation but in reverse. Integration is used to find the function to show us the area underneath a curve.
Hey guys, so today we are going to have some integration, and we have a given 4x cubed minus 2 over x raised to the power of 2/3. Now we have a given wherein the numerator is a function and the denominator is a variable with a fraction exponent. So for us to be able to find the antiderivative of this given is we're going to expand the equation by distributing the denominator to every term of the numerator. So you would get 4x cubed over x raised to the power of 2/3 minus 2 over x raised to the power of 2/3 and dx. So that is the expanded form, no? After that, we have just expanded the given. After expanding is we're going to simplify. Now the simplified version of 4x cubed divided by x raised to the power of 2/3 would be 4x raised to the power of 7 over 3 minus the simplified form of the second term would be just the same, which is 2 over x raised to the power of 2/3 and dx. Now that is the simplified version of the given. Now after some simplifying, we are going to do now the integration part, wherein we're going to use the sum rule to separate each term. So what is the antiderivative of 4x raised to the power of 7 over 3 dx minus what is the antiderivative of 2 over x raised to the power of 2/3 dx. So we have just used the sum rule to separate these two terms. And after we have separated and used the sum rule, we are now going to find the antiderivative of each term. So what is the antiderivative of 4x raised to the power of 7 over 3? So we are going to use the power rule, wherein we are going to add 1 to the exponent of the term, and what we did to the exponent is we are also going to do it into the denominator. Same it is to the second term, and we transferred the denominator to the numerator. That's why its exponent is negative 2 over 3, and we add 1, and what we did to the exponent is we are also going to do it into the denominator. And after doing this, we are now going to simplify and do the math. So 4x raised to the power of 7 over 3 plus 1 would be 4x raised to the power of 10/3, same it is to the denominator. And as well as to the second term, 2x raised to the power of negative 2 over 3 plus 1 would be 2x raised to the power of 1/3, and same it is to the denominator. So we got 4. And after this, we are going to simplify. 4 divided by 10 over 3 would be 6 over 5 raised to the power of 10 over 3 minus 2 divided by 1/3 would be 6x raised to the power of 1/3. And we are going to add the constant c. And after that, we have just found the antiderivative of the given.
That is all for solving for integrals.